are to be balanced by using again the simplest method, that is hit and trial method. That means first of all I have changed this main equation into two equations, partial equation 1 and partial equation 2. Now let us balance these two equations. Balanced equation 1, if we count the number of oxygen atoms on both sides, here are 3 oxygen atoms and this side also contains 2 plus 1, that is 3 oxygen atoms. That means this equation has been already balanced. Now let us balance the second partial equation, PbS plus O changing into PbSO4. If we compare the number of lead atoms, Pb is 1, this side also contains 1 Pb, this side contains 1 sulfur atom. Similarly, towards right hand side there is also 1 sulfur atom, means lead as well as sulfur are already balanced. But if we compare the number of oxygen atoms, this side contains 4 oxygen atoms, but this side has 1 oxygen atom only. So to balance this partial equation, we have to multiply this oxygen element by 4 so as to get 4 oxygen atoms. Now these two equations have been balanced, but in these equations here O is acting as intermediate, which is to be cancelled during the addition of these two reactions. So if we want to cancel O, in the first equation there is only one O, but second partial equation contains 4 atoms of oxygen. So to cancel these two, make this equation, multiply this equation by 4 so as to get 4 oxygen atoms. So in the next step, multiply balanced partial equation by 4 and let us add these two balanced equations. 4O3 plus PbS from the second partial equation, they are giving us PbSO4 again from second partial equation and 4O2 from first partial equation. Here O as well as O of equation 1 and of equation 2 have been cancelled because they were acting as intermediates. So this is also a balanced chemical equation, and we have balanced this equation by using partial equation method. Let us see once again that first of all we changed the main equation into two partial equations, and finally we balanced these two equations by hit and trial method, and in the next step we multiply the partial equation 1 by 4 and these two equations are added to get the final balanced chemical equation. So this was all about the two methods, that is hit and trial and partial equation method. Now essentials of a chemical equation. In this topic we have to study that which conditions a chemical equation must satisfy. It should satisfy these three conditions. First, it should represent a true chemical change, means only that reaction can be represented in the form of equation which is true, means which actually exists, and we can't represent any false or fake reaction. Second is it should be balanced. So the second essential condition for a chemical equation is it must be balanced. If it is unbalanced, then it is of no use. And third condition is it should be molecular. So this equation should be in molecular form and not in the atomic form. So these are the three main conditions, or you can say the essential conditions for a chemical equation. Again, first it should be a true chemical equation, it should be balanced, and it should be in the molecular form. Next, let us discuss that what information is given by a chemical equation. Basically, a chemical equation gives us two types of informations. First one is qualitative information and second one is quantitative information. Qualitative means we will get just quality of the various reactants and products, and in quantitative we can get the quantity of reactants and products involved in that particular reaction. Now let us discuss these two types of informations one by one. First is qualitative information. It tells us about the names of reactants and products. So if we see a chemical equation, we will read their names. So we can get their names, that which reactants are reacting to give which kind of products. This is called a qualitative information. Secondly, it gives us composition of the substances which react and form as a result of chemical reaction. So composition is also given by chemical equation. So these are two qualitative type of informations, names and secondly the compositions of the reactants and products. Next is what kind of quantitative information is given by a chemical equation. It tells us about the number of molecules of the reactants and products taking part in the reaction. So in the first step, it tells us about the number of molecules of each reactant and product, that how many reactants are reacting and giving how many products. Secondly, they tell us about the number of moles of each substance involved. Again, the number of moles means how many number of moles of reactants are giving how much number of moles of the products. Third, they tell us about the mass of each substance involved, and finally they give information about mass, mass volume and volume relationship between the various reactants and products. So this is quantitative information. For example, let us consider a reaction in which hydrogen and chlorine, they are reacting to give HCl, that is hydrochloric acid. Now let us see which kinds of information is given by this equation. First, qualitative information. It tells us about the names, that is hydrogen and chlorine react to form hydrogen chloride. That means names of the various reactants and products we can get from a chemical equation. Secondly, it gives the composition of hydrogen, chlorine and hydrogen chloride, that how many atoms of hydrogen, how many atoms of chlorine. Similarly, it also gives the composition of HCl, means it contains one atom of H and one atom of Cl. Quantitative information means it tells us about the quantity, that one molecule of H2 reacts with one molecule of chlorine to give two molecules of HCl, means it is giving information about the number of molecules. Secondly, it tells us that 1 mole of H2 reacts with 1 mole of Cl2 to give 2 moles of HCl. That means number of moles. Thirdly, it informs us about the mass, that 2 parts by mass of hydrogen reacts with 2 into 35.5 parts by mass of chlorine to form 2 into 36.5 parts by mass of hydrogen chloride. Now, let us read some limitations of chemical equation. It fails to give the following informations. First, it does not tell us about the physical state of reactants and products, means it does not tell us that whether a given reactant or product is in solid state, whether it is in liquid state or it is in gaseous state or aqueous state, means physical state is not told by chemical equation. Secondly, concentration of reactants and product. It does not give any information about the concentrations of the reactants and products, that whether that given substance is dilute or concentrated. Third, it does not tell us about the conditions like temperature, pressure, catalyst, etc. Means it does not tell that at how much temperature that reaction is taking place and how much pressure is there, and if a catalyst is needed or not during that particular reaction. It does not inform us about speed of a reaction, that whether that reaction is slow or it is fast. Fifth, it fails to inform us about the heat changes of reaction. It does not give the formation of PPT or evolution of gas. Similarly, it does not tell us about the nature of reaction, that whether it is reversible or not. How to make an equation more informative? So, in this topic, we will read that how to remove these limitations. In the first step, physical state like solid, it can be written as S. If a reactant or product is in liquid, it is represented by L, aqueous by AQ, or gaseous state by G. So, you have to write S, L, AQ or G just after the formula of that reactant or product. Secondly, for the concentration, we will represent DIL for dilute and CONC for concentrated just before the formula of that particular reactant or product. Conditions like temperature, pressure, catalyst must be written on the arrow. Similarly, if there are heat changes involved, they can also be expressed during a reaction. Here I am taking a general reaction, that is A is reacting with B to give C and D. In this reaction, 50 kilojoules of heat is being evolved, so it can be written on this side. If heat is to be absorbed, that is written on the reactant side. If some PPT are there, means if precipitates are formed during that reaction, they can be represented by downward arrow, and if a gas is evolved, it can be represented by upward arrow. If that reaction is reversible, it can be shown by double-headed arrow, which is showing that forward as well as backward reactions are going on. And in the last step, speed is also indicated by writing just slow or fast over the arrow. If we write over the arrow slow, that means that reaction is slow, and if we write over the arrow fast, that means that reaction is fast. So, here we have discussed that how can we remove these limitations and make an equation more informative. And in the last topic, let us discuss that what are thermochemical equations. The equations which involve heat changes are called thermochemical equations. These are of two types, exothermic and endothermic. The reactions in which heat is evolved are called exothermic reactions, and the reactions in which heat is being absorbed are called endothermic reactions. So, this is all about my topic. Thank you.